Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. How are you today? Today we will talk about application of the derivative by Ms.Rara. Application of the derivative is divided by two. The first is application of the first derivative. The second one is application of the second derivative by Ms.Rara. So today we will talk about continue about application of the first derivative because in the last meeting we already learn about interval of increase and decrease, absolute and the local, finding the local extrema. But today we will talk about the first derivative test. In the first derivative test, from here we are seeing in the left side graph and the right side graph. In the left side, they have increase, and in the right side, they have decrease. If they talk about increase, so the meaning the first derivative more than 0, and then if they decrease, is that the meaning the first derivative is less than 0. So the f should have a local maximum at x equals c. How about this one? This one they have decrease in the left side and the increase of the left side. From here we are see because decrease the first is the first derivative more less than 0, and the second is increase. That's the meaning that the first derivative is more than 0. From here they have c. So in c have a local minimum. This function have local minimum x equals c. How about the last picture? In the last picture, in the right side, in the left side, on the right side, from here we have C, they have this increase. So that's the meaning the first derivative is more than 0. And then you have the slope is parallel with x-axis. No, the slope but the line, the horizontal line is parallel with x-axis. That's the meaning the slope is equal 0. So it's the same with the right side. In the right side, they have decrease. So the first derivative is less than 0. And then the parallel line, and then horizontal line is parallel with x-axis. So this one, the slope is equal 0. Then f should have neither a local maximum nor local maximum at x equals c. Moreover, we know that fx in increase where the first derivative more than 0 and decreasing where the first derivative is less than 0. So the first derivative test, let c be the critical point of function fx. So c is maybe the root, or when you first derivative, you have the c. And then this is the same explain about the third of the picture. So next. So now we will talk about example. So please enjoy my video.
Okay everyone, the question is find the critical points of the function f x cubed minus 3x squared minus 9x plus 6 and classify each critical point as a local max or minimum. So you need to answer about critical point. Critical point have the requirement critical points have the first derivative is equal 0. So you need to derivative about this one first. So derivative about this one is 3x squared minus 6x minus 9 is equal 0. Okay. Since this one is can divide by 3, so you can divide it by 3. So this one will be x squared minus 2x minus 3 equals 0. So you have to root about this function. X minus 3 x plus 1 equals 0. So this root is x equal 3 or x equal minus 1. Stop. After this, you need to find the sign chart from the sign chart. This is minus 1 is 3. So we can take the x before this one or in the middle or in the bigger this one. And then you need to substitute that x to be the first derivative, because this one is first derivative is 3x squared minus 6x minus 9. So let's say I took the 0 because 0 is here, so you need to substitute this here and then get not minus, and then 4 is plus, and then in this one is plus. So this one is up arrow and then up arrow. So local max. So from here we get x more less than minus 1, and then x more than 3 is, because this up arrow, so it's one increase, and this one x more than minus 1 but less than 3, this one is Yes, correct. This one is decrease. Okay, everyone. So that's it for explanation. So from here, this one minus 1 is local. And this one is local. Local max. Where is local max? Local max is minus 1. Local minimum is 3. Okay, everyone? Find the local extrema of the function f(x) equal x power 2 over 3 plus 2. So you need to find critical point. Critical point is the first derivative is equal 0. So you need the derivative about this one. Derivative about this one is 2 over 3 x minus 1 over 3 equals 0. So we can divide it, this one divided 3 over 2. So this one x minus 1 over 3 equals 0. Okay, so this one x is still 0. When you get x equals 0, so you need to find what is the left side of the right side in this chart. So when we put this one 1 in here, so in 1 is the positive, in 1 in less than 1 is minus. This one is down arrow, this one is up arrow. Because it's down arrow, 0 is local minimum. Local minimum x equals 0. So that's it for about. Another question is find the local extrema of the function f(x) absolute x minus 1. So we already know absolute is divided by 2. The first one is positive, which is the x more than 1, and then the second one is minus, which is x less than 1. So from here we get x equal 1, and then from here x equal minus 1. From here, since this one in the right side and the left side is not the same, this one is not defined x1. So this one x equal 1 is critical point. Okay, everyone, since this function just have the two, the right side and the left side, in the right side is more than 0. This one is increase. So this one plus, and then this one's minus. Is this up arrow, and this one is down arrow. 1. So 1 is showing what? Yes, correct. 1 is showing local minimum x equal 1. Where you know this one minimum? Because the sign is the down arrow. So that's it for this question. f(x) equal x power 3 plus ex power 2 plus 15x plus b has a local maximum at the point 1.10. Then find a and b. Answer. Since we know we should the derivative about this one equals 0, this one must occur. So we need to derivative. The derivative is 3x squared plus 2ex plus 15. So in here we already know if x1 we substitute here, because this one must be equal 0. So when you derivative about this one, you need to substitute this one to be 1 and then equal 0. In here you get to a 18 minus 19, a equal minus 9. From here we get the a, and then we need to find the b. Where from we get the b? The b is from here. If x is 1, y it should be 10. So this one 10. So you need to substitute this one to this function. This function is x power 3 plus ex squared plus 15x plus b. Change the variable x to be 1. So you will get the b equal 3. So that's it. Interval where f(x) increase or decrease and the local extrema. From here we are see the graph y equal first derivative. So minus 2, minus 1 and 1. Minus 2 to minus 1 is decrease, and then minus 1 going to the 1 is increase. So from here, so x more than 1 is increase, and then x less than 1 is decrease. So we need to chart sign. From chart is in the left side is minus because this one is decrease, and in the right side is plus because this one increase. So this one is up arrow and the left side is down arrow. So this is 1. So local minimum is 1. Why miss this is 1? Because they have from down arrow. They talk about from the left side to the right side. Okay, everyone? So the values of m, thus the function f(x) equal x power 3 minus open bracket m minus 1 times x squared plus 3x minus 2 have no real extrema. So the answer you need to find, because this talk about extrema, you need to find the first derivative still equals 0. So the derivative of this one is 3x squared minus 2 times m minus 1x plus 3 equals 0. Because they talk about no real no real extrema, so that's the meaning the discriminant is less than 0. So the formula of discriminant is b squared minus 4ac less than 0. From here, we just substitute and then simplifying, we will get 4 times m squared minus 2m plus 1 minus 36 less than 0. So we can divide this one into 4, and then we will get m squared minus 2m plus 1 minus 9 less than 0. So you need to quadratic about this function. So it will be m equal 4, and or m equal minus 2. So we need to put minus 2 and 4, and then you just take to another number of this one, and then you just need to substitute from this one. Let's say I took the 0. 0 put in here. No, 0, 0, minus. So this one is minus, and then the other side is positive, positive. Because they talk about less than, because they talk about half no real is the less than, so this area we will take. So this one, it should be like m more than minus 2 but less than 4. So it's easy, right, to just get the so
Thank you for today, everyone. Please do exercise. Check yourself 6 and 7. Page 99 and 101. I hope you enjoyed this video. This is application about the first derivative test. If you like my video, please like. If you like my video, please like, subscribe, share, and comment for give me energy to doing more about this video. So thank you for today. Assalamualaikum warahmatullahi wabarakatuh.